So in this video I'll be explaining electric circuits. I'll be talking about electricity, and yeah, just bear with me. So it might be a little bit long, but yes, we are going to be talking about physical sciences, electric circuits, right? Grade 12. I'm also going to be attaching the notes so that you may be able to have the notes. So the first thing that you need to understand when it comes to electric circuits for grade 12 is that we'll be having resistance, what we call resistance. So resistance is a measure of the opposing force which is applied to the flow of charge in a circuit. So for example, you have your circuit which has something like this, right? This can be our resistor, and our resistor may be 5 ohms. So resistance is a measure of the opposing force which is applied to the flow of charge in a circuit. Resistance is a wire. In a wire is the opposition of a wire to the flow of charge. So for example, if charge was flowing through this line, resistance is going to be the block that blocks the flow of charge over this wire. So it is caused by collisions between electrons and atoms in the wire. Motors, light bulbs, and heating coils are all examples of resistors, right? So the symbol that is used for resistance is R, and we measure it using ohms. So it's written like this. This is the ohm size. So the resistance of the conductor depends on the, so these are very important. The resistance of a conductor is dependent on, number one, the type of material that will be used, right? Number two, the length of the conductor, right? Number three, thickness of the conductor, right? Number four, temperature of the conductor, right? So the type of material used, this is number one. The length of the conductor, if the length is long, then the greater the resistance. Number three, if the conductor is very thick, then it's going to mean that the resistance is going to be very small. And if it's very hot, then it's going to be more resistant, right? And then we need to also talk about the Ohm's law. So the Ohm's law, the current that goes through a conductor is directly proportional to the potential difference across it, and inversely proportional, and the provided temperature remains constant. So that's the condition. So the Ohm's law states that V is equals to IR, which is equals to voltage is equals to current times the resistance, right? So we also need to talk about ohmic and non-ohmic conductors. So materials, they differ when it comes to its conductivity within the circuit, right? So they are what we call ohmic conductors and non-ohmic conductors. Let me write it down for you. So we have ohmic conductors, and we have what we call non-ohmic conductors, right? So for the ohmic conductors, these can also be referred to as linear conductors, right? So linear conductors, it's something like this. As the current increases, also the potential of voltage, the potential difference will also increase. So this is an ohmic conductor, right? And then we have what we call something like this. Current increases, but the voltage, it increases but to a certain point, right? But this one is called something that is different, which we can refer to, an example being a filament lamp, right? So a graph of current versus potential difference of an ohmic conductor is straight, just like you see here. It's very straight through the origin, so it cuts at 0 and 0. That's what it means. Metals and alloys, they obey the ohmic law. So carbon is a non-metal, but it also obeys the Ohm's law, right? For most other materials, the resistance is not a constant and changes applied within the potential difference. So for some substances, you see that we have this graph. It doesn't always remain the same, like it's a straight line like that. It actually changes, right? And then we usually measure potential difference in current and then use the data to plot a graph between the current and the voltage, right? So the current versus potential difference for an ohmic graph is a straight line like that. And then for the filament, like that filament lamp here, this is for the filament lamp, you realize that it's going to increase, but when it comes to this part, that's when it's going to start having a constant current, right? So, and then for the diode, it's also something that is different, something that we can also say, okay, this is different from what we normally know, right? So what is the first thing that we can notice? The first thing that we can notice is for the diode, the potential difference is like this. So this is the voltage and this is the current. So at some point on this part, it's still constant, in this part, still constant, but then it now starts shooting, going up. So this is for the diode. So the gradient will be now getting steeper, steeper, steeper. A diode only allows current to flow in one direction. So these are the characteristics of a diode. A diode is going to allow current to flow in one direction for that particular circuit. It doesn't allow current to flow in two directions. That's what differentiates a diode. Do you understand? And then small increases in voltage after the minimum voltage result in a large increase in what? Current. That's also another characteristic. So I'll see you in the next video. Don't go anywhere.